Here we go. Zoom in there a little bit. Gonna need space to move around. I wish there was a different. Let's move it in a little bit. There we go. Nice. Yeah. I'm gonna try and load it up. Attach it to the rotor. Get a load on it. Probably doesn't push that much air, really, like by cubits or cubic feet, whatever it is. It looks like it's not going to push much, but it'll slow it down a little bit. Put a load on it. Heck yeah, man, this fan right here. Alright, so we're working with two SG circuits right now. One for each coil on the rotor. And they're both at 3 volts in. But it's a halbach array, so yeah, that's not right. I gotta get a tinfoil strip for this disc. It doesn't have one. But that's pretty awesome. So these magnets in here are aligned in a halbach array. So north is always going to be facing up when it comes to this coil. So it's always going to be facing that way, that way, that way, and that way. Just like that. So the magnets are not facing outward, is what I'm saying. We're going to get some pretty interesting readings. None of them are going to be too large or strong, but we'll get it spinning. Here, let's see, you get some north and south in here, and you get some null zones, like right there. There's nothing there. So there's looks like there's a 0 point. Right there, and probably over here too. No, just right there. Maybe it's too high. That's no. Okay. Did it go blue? Yeah, it went blue. Okay. Well, there it is. Okay, that's weird. It's like there's a spot there that doesn't register on this thing. Maybe it's the thing. I don't know. Right there. That's cool, man. I think that check all the way around in that spot. There's a lot of north-south going on here. And all in between here. Because each one of these magnets should be south and north. See, this one I think is backwards. Yeah. I don't know. That's hard to tell. I know the other ones are right. North, south, north, south. North, south, north, south. North, south, north, south. And this one is north, north. So that's definitely not right. Make sure I got the right one. Let's see. Yep, alright. It works. Let's see if it still works. We'll turn it on. Because that magnet was definitely facing outward. And you can run these things on one magnet. So, let's give it a little juice. Good. It works. Yay. Alright, so I'm planning on putting this fan on this disc, applying a load basically. Need to figure out exactly how to do that. I was going to use these magnets, glue one magnet to the rotor, one magnet to the bottom of this, and then the magnets could do the rest of the work. But they got to be glued, they can't just chill. Alright. So I got this toroidal over here. Well, you know, it's changing a bit. It's more like a drum now. It's not a Newman motor style. It can still counter rotate. But as you can see, I put a cone on it. And it spins very well on that shaft. So that I think we're going to use this method. We have toroidal. I mean, the only reason I call it a toroidal in the first place is because it wasn't on the shaft. You know, it wasn't fixed to the shaft. But now it's like on the shaft, but it spins beautifully, and I think I like it this way. The other way was a bit unstable. I needed to buy a lot more stuff to make it work, actually. I needed rods instead of tubes, things like that. don't know why these aren't sliding like they used to. There we go. I think that'll work. It's like right under it now. Let's see if it'll work. No, I hear it squeaking. Can't be right on top of it or under it if it's not inside it. It's gotta be off to the side. Did I just blow the transistor or something? Yeah, I think this wire. Alright, it's got a screw. Let's try that. Working really good just a second ago, but I might have just blown that transistor. It looked like two wires were crossed. There's only two wires. Hold on, let me take this off. I need to hear better. Yeah, I don't remember it being this hard to do, so I'm thinking I blew the transistor. It's all right. I got more. Oh, wow. Good morning, everybody. All right, I'm going to swap that transistor real quick. I think we're right here, actually. Let me look. Do we have one more in the bag? Yes. All right. And the way this is hooked up, it's real easy to switch the transistor. I could just get the bag open. I'm gonna have to stop that other pulse motor and get the tinfoil on it. You unclip one clip and remove the transistor. it back on. I want to get it as little as possible. So I got a very edgier clip. And then, you know, and if you're using clips, of course, there's lots of ways to hook these things together. Alright, let's give it a shot. Was I wrong or was I not right? Maybe I was wrong. Man, this is really boggling my mind why this is happening. I know it's something simple. What is wrong with this thing, dude? It's like stuck. I don't like that. That one's moving really good. Nah, man. Are we on or off? We're off. Okay. On. Now there is one thing I want to do, and I want to switch out this trigger coil for one that I'm going to put inside this drum. I'm going to get it. Well, I haven't made it yet, but I got one that will fit in there. I'll go grab it. All right, so it's big, but it's smaller in width than this other one. So and then once I get like everything the way I want it, I'm gonna put it all into a breadboard, put it in here. little short. I'm gonna make a new one. I'll show you the bobbin for it. No, it's not on top of it, it's right next to it. Let's see what happens real quick. I think I'm gonna need a new transistor, another one, but let's see what happens real quick. Alright. Let's try that. Drag on this thing. I don't even know what happened. I mean, I don't even know. Could be, well, maybe those cross wires right there. Right here. This is the end. This is the start. And they may have crossed, blowing the transistor. This coil right here, this thing loves this coil. And it runs pretty much every time I use it. It's 1,500 turns, so I'm going to make a coil with 1,500 turns in it, but let me show you the bobbin. Notice the shape and everything. So we're going to put 1,500 turns on this. About the size of a pencil you put in your ear, kind of thing. But here, as you can see, I added this cone to the toroid, making it a lot less toroidal in my mind. But I like it this way. This way it looks like it might even get finished, you know? So, that's how it's going to be. Absolutely. I'll show you. And it spins very well. It's a little floppy, but I mean, I think it's pretty good, honestly. You just get those wires, everything is preventing it from moving very well. You put it inside here. Man, wires, I tell you. They like to move around on their own and stuff. And this will tell them to rotate for sure. Good morning. I'm going to say that periodically. Good morning, everybody. I'm on a little bit earlier than usual today. Might stay on for a while, I don't know. So it's 18 gauge and 32 gauge. There's 3 coils in there like that. They all got about 222 turns, something like that, 200 turns. And they're built conal, I want to say conal. Because one side of the bobbin is yay big and the other side is bigger. So you get something like this. And then the wire gets wound up like that. And here's the edge of the bobbins. So the wire is wound like this. It goes wider as it gets closer to the center. Alright, we're gonna give this a break. Let me make sure you can see what I'm doing. Hey. Good morning. Morning, everybody. Welcome. Alright, we're discussing halbach array load. I forgot to put this in the description, but we got a fan load for the rotor because when it was going 3,000 RPMs, it didn't have a load on it. So we're going to put a load on it. I got a pot. We're gonna put the power through this all generated issue power, and we're gonna cut it by a lot with this pot. Whatever's on the other end of that pot should be good. You know what I mean? It's a 25 watt, 1,000 ohm pot. I don't know if 1,000 ohms is enough, but that 25 watt will work. Alright, so this coil is a 26 gauge and 16 gauge. So they're 10 gauges apart. 26 gauge is the trigger, and then 16 gauge is the drive. It's hooked up with this SG on the far side of the table. And then this one is a tri-filer coil. I got 18 is the drive. The 20 gauge strand is hooked up to the, let me see if you can see, you can't see it. But there's a dark light, a black light over there. I got it hooked up to that. It's an LED black light, so it's not like a fluorescent bulb, but it is a black light. And then, you see here, it's hooked to this SG over here. 32 gauge strand for a trigger. On this one, I've got the end of the trigger going into the positive of the drive coil with a diode. So that's pretty cool. I don't know if it's doing any good. It's not hurting it at all. I measured that. I think here, turn it on. Well, actually, let me get that tin foil strip real quick, man. I want to see how fast this is going at 3.5. Here we go. Let's see if we can commandeer this one. Perfect. Okay, the magnets are in a halbach array. Let me turn on the other power supply. Each one of the SSGs has their own power supply. .5 parallel, here we go. And now there's two ways to run this. You can run them on set or on the magnet, which they are right now at 90 degrees. Or I can move this one to here and it'd be at 45 and it would hit 2 times instead of 1, but they'd each be less in strength than the way it is right now. So it's like having one punch with twice the power, or 2 punches with half the power. it out. $1,147 currently. I tried hooking the SSG up to this, and it won't run. It's like resistance on it's too high, and then when I run the other way, it ran perfectly for a little bit. But then I heard it hiss, you know, like wait, that sound that makes when it's like on, karma on, kind of. Whenever a magnet moves close to it, like hiss. 1,400. That's awesome, man. 1,400 at like 0.6 of a watt parallel. So I don't know how you measure that input because it's not more than 3.5 on either power supply. And this one over here is actually probably drawing less than this one because it's an 18 gauge drive that's longer than this 16 gauge drive that's shorter. And that's still phenomenally low in my point of view for 16 gauge. To only be drawing a little bit less than 300 milliamps is great. It's good. So 0.6 parallel. Let's turn it up a little bit. I mean, we're at 3.5. We're going 1460. We haven't even got our outputs on yet. They're not even on for the SG. Really listen to that, man. That is very rich sound. Let's put up the 9. All the outputs are turned on. $2,400. $29, 3,000. That's awesome. 3,000 is awesome. We're gonna go for more, but I gotta secure that shaft a little bit. Because I had an accident with the magnet hood. I had a toroid on here and I forgot to strap it in. So it started knocking the shaft when it came loose. Yeah, it's not a lot of vibration here, just a little bit. And we hit 3,000 like with ease, man. We still had probably 1,500 more RPMs to go at 9 volts. But it was an ascension rate of like 200 every time it would read. So I mean, that's pretty dope. Now, how do we get this bad boy on there? Make sure we got it right. We're spinning it this way. Where do we flip it over? Oh, let me show you this one. I made this one. It's a little whack, but it's alright. Okay, so they're like scoops. They scoop the wind and they channel it to the inner sanctum in the center here, and then wherever I want to do with it at that point is up to me, really. But there's like holes in this center part that connect to the fan blades. So I thought this was pretty sweet. I'm trying to build something like that that'll channel or funnel the wind to the center, and then from there I can channel or funnel it back into the system. As long as there's pressure there, it should work. At least a little, it should work, yeah. But the key is there's got to be pressure there. Now how am I going to center this little doodad? Let me show you how to do the big ones. Right there, that cord center hole. And that'll center it right on that shaft. But these little ones, I don't know. Let's see. I got magnets all over my room. They're like stashed in places all over. Yeah, I don't know. That's pretty cool. Alright. Maybe I'll try and get some of this glue off of here. I would put that big one on the top, but it prevent me from not. Actually, I won't. I won't put the big one on top. I probably need it too. But after that accident, man, I'm not putting the big one on top. See, it's in hindsight that you know most of the time. I mean, and it's got to be strong enough. The bond has got to be strong. Well, I got an idea. I have a washer that's actually a 42 and 42. With the 1/4-inch center hole. So if I get like a base that's extremely magnetic, here, let me see which. Oh, let's see here. This might even float. North facing up. Oh, not gonna float, but that's alright. Oh, that might work. But it is a center hole. Let's try putting one of these on there. Looks like it might work. Let me try putting it on the other side. Alright, and I think this will be on there without any drag. This is putting it down. Let's try again. No, I need to pry it. Get something to pry it up with. But that center hole is key. You got it. You can't center these without that. No. Where is it? There it is. All right. Oh, I forgot about that. One more tool. Let's see if this will work. Nope. The glue must have gave away. Okay. That's all right. That just means I have to do it first instead of trying to do it in the middle of shit. Excuse me, pardon my French. Oh no. I can get 3 of those, but the 4th one is going to be difficult. Alright, now put this on first. I would have done it first before, but it came into play after I'd already built it, so couldn't really do that. Alright. Oh, let me put this back on the shelf. It's probably a little off. It's alright. Now, let's shoot it. Let's see. South facing up, so it's facing down. Where's my thing? I'm having a mind to. I'm gonna start putting glue on the wrong side of this thing. Yeah, I need to. Here. My bad. sweet. Just let that dry and cure for a minute. We'll put it right on there. Let's salvage some magnets from the gesture. Yay! Alright, here we go. So now north is going to be facing me. That's our mark right there. So north is facing me, facing me, facing me. Yeah. I guess we could just use, well, I think I can get one more off of this thing before I gotta use a clamp. So north, north. Yeah, all right. You get something magnetic. We'll see what happens. I think it'll work to a certain point. It's not very strong bond though. I feel like maybe putting that, yeah, I can't. It needs to be open, more open. So I'm going to start it off at 3.5. I want to start it at 9, but I'm not going to do that. Because I don't know if this thing's going to fly off. I mean, I have a feeling it's going to fly off. I think it's pushing the air down. Down and out. 753. That's a lot lower. Sweet, man. That's great. It's a little wobbly, but I think I can fix that. This is like a bathroom thing, I think. It's blowing the air down. Or I flipped it on the thing. I don't know. I downloaded it off of Tinkercad. Well, use the file from Tinkercad. I think it's working wonders, man. It's great. Just needs to be a little bit more flat, and I can do that. Heck yeah. And that halbach array is great, man. Instead of having the magnets either facing inward or outward, north or south, you have them facing direction you want the wheel to spin, north facing. So it's pretty neat, I think. One second. I'm going to take the fan off. I'm going to do a speed run real quick. I got to get the glue off of the magnets. See, that's smooth, but this is not smooth. Yeah, let me not do this, but initiate the speed. Let's just put 9 volts in. Start there. If I can get this off, let me get a flat connection. I'll put the fan on. Alright. Here we go. Listen to that pickup, man. It's so fast. $1,300. Sound healthy, does it? I got an idea to make it more healthy. I got to screw in the base a little bit better. I told you I had an accident with one of those big round toroidal magnets. Take one of these. And it was wobbling around the shaft, you know, it was shaking the shaft pretty hard when it came dislodged. So I just gotta screw those back in tighter. They're still in there, they just need to be tighter. Alright, let me grab my drill. This is gonna take a while. I might need a heat gun to do that with. Something hot. Alright. But it's an easy day today. Hey, Tiggs. Not only is there this one on the top, but I have one underneath holding this one in place too. Hey little guy, how you doing? And then I got this little bearing on there. I thought it would spin better. Let me see now. We don't really need this. Maybe just this pointed upside down. Yeah, let's give it a shot. Now we'll put that bigger bearing on there. But this way, you got two flanged bearings. One facing down and the other one facing. And then this one here is upside down, so when they lay on top of each other, it's like right in the groove. And I remove some. You know, I think what we're going to do. We're going to put the big one on, and we'll put the little one on upside down. That should give us perfect height. Put our magnets right in the hole of the coil. Yes. Okay. We got 32 gauge coils up to wazoo that we can add to this wheel. See how much electricity we can get, but we're going to run it through this 25 watt 1000 ohm pot. What's that noise? Might be that bearing. Maybe we don't stack them. So now it's the south going counterclockwise. We'll do 5. This is 5.9. Those amps were getting really high. 2100 at 5 volts. And they're still getting high. That's the halbach rate. Wow. Wow. Make sure I got that right. No, that's not it. That's the one. Wow. That's fabulous to start the morning off with 32, and it was going faster than that because I had to turn it off. Oh, that's so cool. The fact that nothing's broken, even better cool. This is 3 volts. We're going to see how fast we can get going. 3 volts. We'll pick this glue for a little bit. We're going to let it build up. And then I'll hook up some generator coils and we'll throw the pot on there. And we'll see what's up. Granted, it is only 1,000 ohms, but it handles a lot, so I think it will be alright. Yeah, this stuff is hard to come off the way it is. Let's see here. 1800. .9 of a watt. That is fantastic. Yep, 1870 is probably going to be our max with this number. So I used to group with a guy, and he said that, so you make psychedelic pulse motors, because I would paint all my rotors. I thought that was pretty funny. I'm like, no, not really, oh, kind of. I just get bored with it, and I like to paint them every once in a while. Like this one, I want to paint equally 4 sections, black and white, in like a counterclockwise direction, black and white. And then hopefully it'll make like a really fast spinning record design. I think that's better. I don't think it's perfect by any means. I need something sharp, but I have a Swiss Army. But so what are the benefits of running halbach than running all north or all south? Or half and half? I mean with the halbach you've got half and half happening every magnet, so I'd say that's good. I don't know, should I use, I got sandpaper or a sponge, sandpaper sponge. See if that'll help. Let that slow down. This stuff is really stubborn. I'm gonna try this. I mean, like it's not all gone, but it's flatter, a lot flatter. It's not as bumpy. Five. Here we go. I can feel that. That feels great. Yeah, that's a lot better motion with the fan. Woo! Heck yeah, let's get a speed test at 300 or 3 volts. $951.9 RPMs. That is a lot less than $950. Then it would be without the fan. That's just that's what I'm saying. Alright, that's half of it. That's half of the efficiency test right there. And it did go down about, let's say, 800 RPMs. And I didn't put it in the description because I wasn't sure that I was going to do it, but now everything seems to be falling in place. And it looks like I'm probably going to end up doing that. So, what I believe needs to happen with this pot is we are going to plant our coil right about here. Let's just do it like this for continuity. Gotta stay in a straight line. You gotta walk the straight line. And we're gonna hook each one of these ends to the power, and we're gonna hook the multimeter to the center. And just make sure this is somewhere in the middle. Now I need 2 clips, 3 clips. And then I think, actually, I think we're going to go through the pot, and I think we're going to do a bridge rectifier as well. Some of these are a parallel connect, some are not. I don't know. I'm just doing what makes sense to me. I have no idea if I'm hooking this up right, honestly. I'm putting it in the middle, basically. Oh yeah, the bridge rectifier. I think it goes into that now. Because if it's going to be a series circuit, then it's got to go into the next piece, which is this. You know, so this is the problem that I'm having right now. So now I got both ends of can't work. No, I'm seeing it now. This probably can. And we'll get our reading off of the bridge rectifier. Right. It's funny, I can't see it. I know it's near though. There it is. Right in front of my nose. Now this 10 ohm or 1000 ohm resistor potentiometer might not be enough ohms, but we'll see. Need a clip, 2 clips. Morning, everybody. How's it going? Decided to get an early start today. We'll be doing this all day, I think. All right, let's see. Just hooking up the multimeter to the bridge rectifier. I'm dying to see what this is going to generate with the halbach on it, instead of just the north that I usually do, or the south. Oh yeah. Let's see. I don't know if I'm doing this right. Let's try. So I got the center one. So hard to tell, like, I'm probably not even doing it right, that's why it's hard to tell. I'm going to shift the camera a little bit so you can see better what I'm doing. know I'm supposed to hook all three up, but I can't figure out what and where I'm supposed to hook it to. I want to get the meter reading. Man, I need to watch that again. Ugh. So it's like generating. So it says 34. 34. See what it says without the plot in there. 34. So no, that's. We can take this out. I gotta find a different load to put resistor, some kind. That's an interesting wave. So we got a load on the rotor. We just don't have a load on the output. Now these SGs, there's already a load, I'm pretty sure, on the output. Because it works fine. I plug it in and it works fine. But I'm just saying, in the case of the electricity being generated by the coils, I need to find a way to get rid of the quote-unquote froth, so it doesn't look so vivacious. I mean, seriously, I'm getting like 500 volts without resistance. I need to find a way to find out how much of that energy I can actually use to do stuff with. And I'm gonna bet that it's gonna be very low amount of energy, even though I'm generating 500 volts, that I can actually use. And I love the beer analogy of the whole thing. I mean, that's a great analogy. Okay, so we turn the power off and that vicious spiky line disappears. So I would say that would be definitely electrons in motion that vibrate part of the scope there. See, let's just look at the difference real quick. I'll turn this on. Whew, dang. really don't feel right with that fan. It's working good so far, but I have a feeling about it. It's probably not a good thing that I have that feeling. It's holding fast so far. But again, the only thing holding it on there is the magnetic connection between the two magnets there. That is awesome, man. It's chaotic, but it's freaking cool. So, yeah. Let me show you what I'm doing next. On the toroidal, I'm having lots of trouble finding a position for the trigger coil. So I was gonna make a trigger coil like this with 1,500 turns on it, or maybe 3,000 turns. And then it would fit like right in there next to the coil, and that would be good. I mean, I wrapped them all with the trigger coil, but when it was done, not even all three of them together would trigger transistor. I tried it. And I've run series trigger coil before. I've done it before. It works. It's not like it won't work. It's just there wasn't enough copper there to get enough voltage to trigger. I was worried about that, but then I'm like, nah, I'm not going to worry about it. And then I'm like, it's not even going to be toroidal anymore, but, you know, I'm not really worried about that either. So that'll end up being cool once I get it all finished. But first I got to make sure you wrap this and then make sure it works. So I'll put it in there and I'll test it. I gotta use my transistors more smartly though. I think it still works. I don't think it says it doesn't work. Just, I think where it falls. I don't know. It should be all right. I know what we can do. I'm going to use the pot too. Huh. Alright, so now that we got all the power going into here, we'll hook the pot up to this. Where I put it? There we go. I think this, and then we'll ground the COM port. We'll have the middle connected. Jeez, man. It's all good for me. I mean, these are just long. Things are heavy. They're drooping. See, I think these two transistors are still able to work, but I might be mistaken. No, that's not going to work either. Oh yeah, well, that's power. But that's supposed to be what we're changing. Let's give it a shot. I don't know. Let's see what happens. Need to hook it all the way up first. That's interesting. Come on, man. Dude. Yeah. Wow, that's a steady 20 volts. That's weird. All right, I'm going to wiggle the pot around and see if we get a different reading. Yeah, that's not right either. That's so weird. The meter's not even plugged into anything right now. It's coming back from the negative side. Maybe it's being plugged into the switchboard over here. Well, I'm not too worried about it. Wow, man, that air is nice. 6 volts. 3 output. Got a light down here and a black light over there and another light over here. We're running 2 SGs. 2 SSGs. One right here and the other one's over there. We're putting in 6 volts. 6.5. Alright, we're going to jack it up to 7. 8. 9 volts. 9 volt battery. Oh yeah, that's putting a great load on there. It's a great load, man. That is going way slower. But it's still going pretty quick. So, I mean, I would like to hook this up, but I'm going to make that trigger coil first. Trying to get at least 1,500 turns on it. Shouldn't be a problem. This right here, this is 1,500 turns, and this one works really, really well. There we go. Now you can see what's going on. I tried to zoom it in so you guys can see what's on the table better, but then you can't see anything that's going on. So there we go. There I am. There we go. All right. So I don't know. This right here is one of my best coils. It's behind the meter. It's a trifilar, 18, 20, and 32 gauge. 666 turns. Awesome coil. But then again, it depends on what you're doing with it, right? And for a Newman motor, it wouldn't even be applicable. You know, for, you know, even Bedini SSG, this coil is tiny. Okay, it's not even atoms. It's nothing like that, man. It was just me being like, I'm gonna make a coil with 666 turns in it. It's gonna have 3 separate gauges, 3 separate strands. It's gonna be wound parallel. Bingo. And I believe it is wound clockwise. This one is wound clockwise as well. So, I mean, and it's probably wound clockwise because my my automatic rolling machine, when you do it counterclockwise, everything that gets it tightened down untightens, and it gets loose, and then it falls apart. Not the machine, just the coil operation falls apart, because the thread, you gotta just flip the bolt over, and then it'll work just fine. But the way that it is, when you do it counterclockwise, it unscrews the bolt. Just a matter of time, really. This little fan right here, I made this last night. I'm like, dude, okay, we're gonna channel wind. So we scoop it up with our little scoop. It goes in the channel here through the hole in the center, and all this wind gets collected here in the center. Either goes through this way or this way. But if we cup it, if we put like something around it to catch that wind and then channel it back into one of these cups, yeah. Ooh. We'll have we'll have this little fan powering the pulse motor. We're gonna do a speed test. I know I've already done one, but we're gonna do another one. Alright. So what's neat is that this SSG circuit turns the light on at 5, 6, let's say 6. Wow, I don't know, did I blow another transistor? There it goes. It was short, the coil was shorted, so it was acting as a brake. That is so stable. Oh my God. $4,500. Jesus, that's fast. Woo! Yeah. Let me put the coil right back up there real quick. That's awesome. So I'm guessing that the shorting of the coil does the same thing as running a capacitor in the coil. All right. I'll be right back, ladies and gentlemen. Hey, hey. There goes one more place. All right. Here we go. I'm gonna unhook whatever it is. It was so hard for me to tell if there was even any kind of difference hooking the pot up to the coil. I just blew out a candle, man. That stuff smells great. Paraffin and a wick. Ooh. Good. Alright, so we gotta go AC. And this is a 12-volt system. And I can't imagine what this thing would be like at 12 volts. Seven volts. This is a halbach array in the rotor. All norths are facing this direction, clockwise. So every time the magnet is passing that blue coil, both poles are hitting it. So we're at 100. Now, I don't know, like if you did all north, if they could be more right now. But I heard alternating north and south is better for generation. Huh, how did I not have my tack measure? Jesus. Here it is. $22.55. 200 volts. I'm not going to look at the amps because it's not hooked up right. $3,000. Got a lot of vibration in the shaft. Right around 3,200. So I'm thinking that last reading that I did, it was 4,000 something. I accidentally hit the max. We get going about 3,300. Heck yeah, man, that's awesome. Alright, now. Oh yeah, I can feel that. morning, ladies and gentlemen. What's up? It's Papa Bale. Welcome to the channel. It's got an early morning start today, and I've been messing around with my pulse motor. I've been applying different loads, and we're trying to get it to the point where it's displaying the amount of usable energy. Because, I mean, I guess the readings, naked readings, don't mean much. You gotta do stuff to the readings for it to, and it's true, it's so true. I mean, all that froth can do is light a light bulb, and that's it. That's all it can do. It won't store in a capacitor, it won't do anything but light a light bulb. So you gotta filter it through resistance. You gotta like get it into its range of acceptability. It's like you're trying to plug it into the other pulse motor, and the other pulse motor is going, no, this isn't going to work. At least that's the way it's been with me. It hasn't really mattered. But I got somewhere with the back EMF, with the flyback, I got somewhere with that. There's something that I like to call the SG extension. I can just clip a clip to this collector in the SSG, and it should power the next whatever I'm connecting it to. If you're not using SSG, you can do the same thing. The collector has got live energy in it that you can extend. You can send it on without barely any loss at all to the next thing, the next pulse motor, the next light bulb. It doesn't matter what it is, it'll work. Because you're using the same energy that you're putting in to make the transistor run in the first place. It's the same good stuff. That way. When you collect, then you gotta use a diode. It can't be an AC where it oscillates. It's gotta go in one direction. And I think these circuits utilize the flyback already. I mean, all I gotta do is flip the switch and it'll happen. And that's why they call it the generator. It's a combo SSG generator circuit. And I mean, I was trying to charge these batteries, like do a flyback loop with the output into one battery and then a relay to the drive battery. So it would go, you see how that might work? If you're generating enough power here to charge the battery every hit, then every hit, the battery gets charged. And it should perpetuate, but it never does. It never does. It gets close. But as far as I know, there isn't one that's still going. Maybe in a museum there's something, but that's been stopped and started several times since it was built. It's just yeah, and it makes sense in my head too when I do the math. Yeah, it should work, but it doesn't. It won't. Now there are miraculous things that do happen, and that can happen, and that is cool. I don't think that's one of them. I think that it goes until the person turns it off. Until, you can't, nobody, nothing. It's just, it doesn't happen. There's no point in it happening because nobody, you would die. And if you didn't tell somebody how to work it or to watch over it, it would just, no. And there's that fantasy that you bury it behind a wall once you start it, and then like 25,000 years later somebody finds it in the wall and it's still spinning. No. No. I mean, if that happens, man, I will jump for joy, but I don't believe it. And I'm not being, not even like all anal, like, it's not gonna run because your parts are gonna rust and you're gonna get more and more friction as time goes on. Whatever, dude, that's not why I'm saying it's not gonna work. You could have zero friction in the perfect environment, okay? I'm telling you, man, it's going to spin outward, okay? That's what everything does. It spins away from the source, okay? It's constantly spinning away from the source. And that's, that's why if this earth is made of water, it's going to be a giant ice cube when this is all over. It's just the way it's going to be. And a lot of things are going to be that way because they rotate outward from the sun. Their sun, our sun, any sun. That's how it works. Because what started the sun was a big explosion. I doubt that the sun was even on fire when it was first born. You know what I'm saying? It's like, I don't think, and then when I hear it, it's like, come on, man. Seriously, you can't be teaching that to people. And at least you gotta have a disclaimer. This is what I believe. Or this person believes it and I agree with him. Whatever you gotta do. But you can't preach it like it's gospel when you don't have a working model. Okay, you just can't. And what I see, I see some great stuff, brilliant stuff. I see salvaging going on. I see Tesla coils being built. I see, using a pulse motor to run something else, using a Tesla coil to actually power a different device. And it's neat how a Tesla coil will transfer its resonance via one wire to the next, to the next, to the next. As long as it's a conductive material, that essence of the Tesla coil will transfer. And I think it's awesome, man. And I've seen the field vibrate on its frequency. And it's channeled. It's it vibrates at the frequency, but then that is pulsed. It's really cool. And I can do that with my pulse motor too. I hook up a PWM to the power supply and then run it through the trigger coil. Boom. And it's supposed to give you more torque, but I never experienced that. Maybe it did. It slowed it down so much that I just didn't bother with it again. Yeah, man, there's lots of people out there doing good stuff. Me, I'm learning as I go. I am definitely producing some stuff here. I'm utilizing other people's stuff. Hopefully I'm getting them some traffic. This toroidal, if I could get the frickin' shaft to be straight on both sides, that would be perfect. But I found the best way to balance the toroid in the middle. In the middle, what I mean is up off the ground in the middle, here, is to make that cone. This cone right here. And it's got double bearings in it. Okay? So what it does is it has a big bearing that fits in the funnel, and the funnel spins on that bearing. And the bearing on the inside is on the shaft, and the shaft the rotor spin, you can spin it either way, and it'll go either way. So hopefully it'll go the opposite way once I get it hooked up. And then that trigger coil that I'm working on, Gerald said that I should try one the size of a pencil. So I'm gonna wrap like 2,000 turns in one that's like half, it's like that big. It's like 7/8 of an inch high. It's like, looks like a little eye bar. I'm gonna put 2,000 turns on that. It's gonna be hopefully 500 more turns than this, because this one works really good. See how it's nice and like centered pretty much. Just that one of these shafts is bent. This one's good, this one's bent. There's a magnet in the middle, so you gotta put one in one side, one in the other, because the magnet is dead center in the middle. So lining those up sometimes, I don't know what it is. It probably is just the pole is bent. So if I like take it out, but taking it out is going to be the hard part. I'm not looking forward to doing that just yet. Because that was like, yeah, I'm going to put it in here and it's going to be good, but I couldn't tell just by looking at it if it was straight or not. Rolling it. Because it's not a huge bend. It's not like very noticeable until you get it in a position where it has to be straight. Oh, wow, it's going to be hot today, guys. It's going to be hot. It's going to be 60 degrees today. I think I'm going to go for a walk pretty soon. I'm probably going to continue though for a little bit. Let me check the time. We're about 45 minutes away from my normal start time. So we'll I love this fan though. It's working like a charm. That's great. There's an iron core in here. And it's actually repelling the magnet. That's going to be cool to see. Alright, I need Hopefully I got these hooked up right. Now, some of these coils I wind by hand, and I do try to do those counterclockwise. Right, let's see how much energy we're getting out the two coils. It's really tricky with these older coils because you don't remember how you did them, and whatever you wrote on them is now smudged off. Especially if it was a good coil, one you like using a lot. There you go. See, one coil will eat the other coil, but the one coil was bigger than the other coil anyway, so still got a plus sign. Sometimes they'll zero each other out completely. You get like 1 or 2 volts. Just a very slow increase. So the iron core is causing a little drag. About 300 RPM of drag. The automatic nail file. Awesome. Let's put a little bit of sandpaper on there and we're good, man. Good to go. Sell it to Taco Bell for $1 million. We're good to go. I'm just. That'd be pretty freaking cool though. To like get like an emery board. What do you call it? Sand texture. Get that texture on. Put it on in between the magnets. All right. Man, okay. So I'm gonna put. No, that won't. I don't think it'll work. I'm gonna try one. I'm gonna try the blue coil. I'm gonna like short it, but I'm gonna put a diode in it. All right. Let's see what happens. I think it's going to slow it down quite a bit, but it might speed it up. Who knows? Somebody knows. My screws might be too loose to run it like that. so I can play with it some more. Nice. That is nice. I think that is actually BEMF. That's 43 volts. In order to really get a good glimpse, I should probably change it to a Schottky. From a straight rectifier to a rectifier Schottky diode. This one does 15 amps. I don't think we're making amps. It does 45 volts. But I wonder. All right, let's check it out. I guess we'll just hook this other one up the same way. And then we'll connect them in series. The two diode connections we're going to connect in series. Oh wow, it is not even hooked up. Hi, Tiggs. What's going on, kitty? Come on, man. Just then I got a lot of green clips in the same area, so all right. We know that one's working, so we're gonna if we don't get this right. Now we just gotta switch them. kicked. You're a good baby. All right. All right, I'm going to swap the two leads and just to see if we get a higher reading. If not, that's good. We're going to combine the two. We got about 11. Whatever coming off of this one. Yay. Okay. I got it right. Alright, so what we want to do now is we want to connect both coils in series and send it to the multimeter. So this is back EMF being collected right now. Because we all know 18,000 turns of 32 gauge would be generating way more of AC or DC. Way more. Way more. Way more. Way more. We got spikes going up to about 56. This is good beef right here. Let's check it out. That is awesome, man. That's great. That is hooked up, I believe, to the 18,000 turn coil. This one. But I want to get a reading for both of them combined. So and you see that the rotor is going a lot slower because of the shorted coils. But now if we could hook them in series, we're gonna it's probably just not gonna start at all. But we're gonna check it out. I need to get a couple of clips. Wow, I've used almost all of my stash of clips. I was expecting a way bigger mess. It doesn't look that bad. Not bad at all. Seen it look worse. Funny, considering. All right, so we're gonna do a series. So the cathode, we're gonna connect to the cathode. And we're gonna connect to the anode of the next coil. Cool. And then we're going to hook this. We're already hooked to it. I just got to rearrange. this one's going to go here. Yeah, let's give it a whirl and see if we get a reading. Oh, it's off. Yeah. So I hooked both coils in parallel, and then I'm hooking the parallel coils in series. So let's see if this works at all. So it looks like it's going to be better to run these either in parallel or individually. Because those readings were really, really low. Do you agree? Compared? No. I hate that these are rubbing off so much. Yeah, I'm struggling this one, and then I can't really see it. Really, it'll be good. The stripe was visible, but sweat. We'll get a good reading off the other one. The blue one. So I could probably charge 2 caps at the same time. Trying to zero in on 12 volts. 12.2. Now I'm going to hook up, to the best of my ability, a load to this coil. See, because this one that was generating about 400 volts DC on the bridge rectifier is now generating 17.3. It's different. And I know this isn't right, but about 400 milliamps. That's brilliant. Now, what am I going to use it on? "12 volts with 2 coil loads." So we get 21 Honda. Wow, it's moving. Probably has something to do with the halbach array. It's gonna stop, slow down so fast. Maybe not. It's slowing down a lot faster, but not as fast as it did that one time. I was like, yay, we found a break. And it was just the coil shorted out. Acts as a really good break. But not so much with a diode on it, but just connected to itself. But the diode, even with the diode, it works pretty good. I'm going to try and spin it the other way now. Put the fan back on it. Hey guys, what's up? It's Papa Bale. We're just chilling this Monday afternoon. So yeah, there's a tremendous load. Even with the dual drive, it seems to be dragging ass. So this is a 12 volt system though. He reminded me. Wow, these lights are bright. Heck yeah. Got 3 lights lit up right now, and they're all in parallel connections with the SG and the trifilar third strand. Alright, so we're going to put all of our loads on the rotor and the motor. Motor loads are already on. Motor loads are already on. Now we're going to do the rotor load, and we're going to take our readings. If I remember to take the readings. Alright. Start off at 9. 12. Wow, okay, so it says, oh, 1,000. So I said 9,000. That's about right. That's about right. 965 RPMs. 936.1. So it literally cuts the RPMs by more than half. A lot more than half. That's great, man. I don't mind it slowing down a little bit. Heck yeah. So I printed this off last night. It's iron infused PLA, so it moves quite solid. So this little contraption came from my own head. Like, what is it? Well, they're tilted slightly like so, so I believe that if this got going, it might lift off. I'm not sure. But they're hollow on the end, all the way through to the middle. And if I encase this with something, or I have like a tube of some kind dumped back in here, it'll recycle the air that it catches. At least some of it. You know, it might not be a big deal because it's so small, but I mean the idea is the air goes through and out this way, because all the air is going to be coming in to the middle. So it's not like it's going to shoot straight through because you got pressure on this side. So it's going to be shot out the middle where there's no pressure. I think it's dope. I think it's cool. Can't wait to try it out on something. It is hot today, man. I can feel it. The toroidal is in a good spot right now. I just need to make a couple of adjustments. Need to make the trigger coil. It's going to be 1,500, my bad. 1,500 turns. If I can fit 1,500 turns on that, that would be great. And then this will just go right in here. I'll find a perfect spot for it and plop it down. And since it's just, you know, that thick, I'm pretty sure that well, we'll see, because it's way different size than the coils in there. So we'll see. This one works pretty well. It's 1,500 turns on the outer rim of this coil bobbin. This is a solid coil right here. It won't generate a bunch, but it'll generate solid electricity. Like, it'll easily light a light bulb. You know, do a lot of things really easily. Here's another one that's probably similar to that one, but it's a different configuration. It's a little bit smaller and a little bit thicker. I used that to trigger, and it was okay. I mean, the weight was a little weird, but that was back when I had the poles going through here. I realized that wasn't going to work, and the way with my poles anyway, they're all bent. They all have a bend, they're kinking them somewhere, and it's from use. It's from using them a lot. I'll probably end up getting some new poles. I got another magnet to mess with, so just like this one. I think I'll be righteous. See if we just put that in there. See, that spins very smoothly. That's going to work out just fine. Back in there. I hope it's going to remain okay. Yay. So it'll be toroidal from this half and it'll be coil from the other half. Yay. It's a win to me. Especially if it kind of rotates, man. That'll be great. But I think that trigger coil I'm going to make is going to make all the difference in how this is going to be going. So honestly, there's a total of about 666 turns in this entire thing. There's like 222 turns in each coil. So this is the B EMF off of the blue coil. And what to do with it, I don't really know how to like yoke it that well. I would like to charge a cap, but I don't use caps that much. And you know what? That fan might be upside down. But you know what? I think it's still pushing air. It's just pushing toward the table. I'm gonna test this battery. Alright, it says 0.28 of a volt. I'm not exactly sure if messing with this is going to be a good thing. Let's try it though. I'm going to unload one of the loads. We're going to start at 3 under the threshold, and we're going to move up above the threshold. This battery is so low that I don't know if it's going to charge. But we are going to check it out. One more time. Yeah, that already says overload. Man, this is real annoying. Alright, there we go. Just everything is tucked in a little crack right there. Right, so I think I missed something. This might have been a problem. Problem was. That looks a little off. Yeah, I don't think this battery is gonna work. It's dead. Something on the inside is not right, and it is not gonna charge. I mean, it goes up to like 27 volts, and it's like a 12-volt battery. That's not safe. And then it goes all the way back down to 1 volt or less. So, waste of money. For a guy that doesn't know how to use it, it's a waste of money. And everybody tells you need it, be sure you know how to use it before you get it. It's not the same type of energy. I mean, it is. It's hard to explain. I mean, I can use my wall charger. It won't charge this battery now, I know that. But I mean, it's supposed to charge the SLA batteries, and it won't charge this one because it's broken. That's what I mean. That's alright. Well, not really. I'll probably get some more batteries later on. That thing weighs a freaking ton for it to be broken. Now, what do I want to plug into these coils? Let's check the cap bank. We'll look at the cap bank. All right. And look at these little devils, man. They really pound. It's like 85% iron, 10% copper, and 2% or whatever the rest is, polyurethane. Yeah, we're going to test it, and then we're going to charge it, and we might even use it. 3.8 volts. And the cat bank is working, right? We just can't hear it. We're good. I hear something, I don't like it. Here, let me make sure all my connections are good. On this side. So it's a 16-volt super cat bank. Now that looks like a bad transistor, doesn't it?